Folks, today we're going to be talking about money. Money is important. We have two different formulas. We have the PERT formula, which I think you've seen before, and the regular interest formula that you've probably seen before as well. And here it talks about what every single letter means. P means the same thing for both of them. E is just E, the natural law of base. R in the same, or both in the same, the rate. T is time, and N is time, number of years usually. And the last thing is K is number of times something is compounded in 1 year. So if it says daily, that number would be 365. If it says weekly, that number would be 52. Monthly, that number would be 12. Like biannually or something like semi-annually, that'd be 2, yada, yada, yada. Okay? Basically, all this stuff is just plug numbers into the formula. So if it says compounded continuously, we're using the PERT. If it doesn't say that, then we're not doing it. So we say Sam starts with $800. We're just following this formula. We always use decimals when we're talking about the interest rate. Over the time, it's compounded every month. So 12 over 5 times 12, 5 years times 12 times a year. So we get that. What I would recommend doing is multiply that first. That gives us 60. Then come back and do the 0.03 divided by 12, then add 1 to it, then take that to the 60th power, multiply by 800, and you get $929.29. All right. For letter B, it says continuously, so we're going to use the PERT formula. Still starting with 800. Now we're using E. My rate is still 0.03, and time is 5 years. So once again, I would take our 0.03 and 5, multiply that. That gives 0.15. So that gives 0.15 right there. And then take E to that number, then multiply by 800, and we get $929.47. So not much of a difference there. Usually continuous, when you can continuously compound something, it grows pretty quickly. In this case, 5 years is such a low interest rate, doesn't grow that quickly. All right, let's move on to, we only got 2 left here. And they work differently than those. All right, so it says how long will we should take $5,000. So then we have 3,500 over here. Doesn't say continuously, so I'm not doing that. So 1 plus, then 0.05 over 12, and then 12t. I don't know what t is. That's what we're trying to figure out. So first thing, divide both sides by 3,500. So I get 1.429 equals, do all this stuff right here, you get 1.004 to the 12t. Well, we have an exponent that we're trying to figure out. Remember, we take the log of both sides. So log of 1.429 equals 12t, because that's what we can do when we have a log of both sides. We can move this guy out in front. So that's what we did here. And then the last thing I'm going to do is I'm going to divide by everything that's not t on that right-hand side. So 12, and then log of 1.004, and 12 of log of 1.004. So when you do all that, be sure you do your PEMDAS correctly. It's going to give you 7.45 years. So if you want to say about 7.5, that's cool. Last one. Mary invested $2,000, and we'll see how long it's going to take to double. So that's 4,000 equals 2,000. Doesn't say continuously, so we're not doing that. We don't know the rate, but we know it's compounded quarterly, so that's 4. And then 4 times 7 will give me 28. All right. Then we're just solving this like normal. First thing, divide both sides by 2,000, and get 2 equals 1 plus r over 4 to the 28th power. And how am I going to get 28th power to go away? Well, if we take each side to the 28th root, or 1 over 28, 1 over 28. So when we do that to the 128, you get 1.025-ish, and you get 1 plus r over 4. So from there, excuse me. From there, we're going to subtract 1 to solve for r. So we subtract 1, I get 0.025 equals r over 4, multiply both sides by 4, and r is 0.1, or 10%. All right? So this is really just an exercise in plugging and chugging and reading the problem carefully, and sometimes you got to work backwards. All right? Good luck. See you later. Bye.